Again, this is the homework for 2.3 that was asked about in class. So first things first, 2.3 number 17. 17 had to deal with a triangle, ABC, C being the 90-degree angle here, and the measurement for angle A is 32.6 degrees. Little a, which is the side opposite angle A, is 43.4. And it's in inches, so let's go for it here. So the first thing to do, probably the easiest one to do, is just to get angle B. But let's go with labeling all the little stuff that we know here. So little b is on the other side there, and little c is the hypotenuse. So angle B will be, since it's a complementary angle, it's going to be 90 degrees, subtract 32.6 degrees, and doing a little bit of work there, and doing some borrowing as well. Gets us a 4, gets us a 7, and a 5. So how about angle B is equal to 57.4 degrees. I put a little box around it here. That'll be my final answer. So next I go on to figure out what else do I want to know. I guess I can figure out the relationship between little a and little b. And so if I think about this here, this is going to be opposite over adjacent. That's opposite of adjacent. That's tangent. So we have tangent. Tangent of A equal to opposite side divided by the adjacent side. And this one's going to be the two-stepper, right? We take the B value, we multiply on both sides, we take the tangent of the angle, and we divide it. So B goes on top, or B is equal to 43.4 on top, tangent of 32.6 on the bottom, punching this into your calculator at this point. And you should get a 67.9 from the calculator to the nearest tenth. Alright, then we have another relationship here. Now you could do, if you want to, you could do Pythagorean theorem right now with 43.4 with the 67.9, and again you just might get some error over here, right? So Pythagorean theorem, you can use it, except you just might get error. So we normally like to still keep with the things we know or we were given. We're given the angle measurement, we were given the opposite side, trying to get to hypotenuse. So opposite over hypotenuse, that's sine. So sine of 32.6 degrees is going to give us a 43.4 over the hypotenuse. This one, again, multiplying the c on both sides, dividing by sine on both sides, gives us what we should plug into a calculator. And once you plug it in, you get yourself an 80.6. So for the final answer, since we were given everything in inches, or the sides in inches, we should conclude them in inches. So little b is 67.9 inches. Boxed for final answer. The c value is 80.6 inches. Boxed as final answer. Alright, hopefully that helps those of you that were struggling with it here. Jumping to 2.3, number 51. 51 is, oh boy, this is fun. This is the cube, and this is the way I would draw a cube. I would draw almost like another cube right here, but not filling it in, just the outside corner. And as you fill it in, as you go in, you're going to put little dots to bring it in, dots to go up, dots to go the other way here. So see if this will make sense there. See if that kind of looks like the book as well. And let's label each of the pieces here. So that's A, E, that's the F, B, labeling, keep on going. And I think that's all of them. Alright, what it says is that each of the sides on the cube is x. So I'm just going to label one of them as x. And then it says, what is the angle measurement that's formed between the diagonal of CF, right here, there's CF and CH. Alright, so let's go for it here. So if that's x, well, we also know that's x and that's x. And we're trying to figure out this little triangle right here. So I'm going to call this triangle CDH right there as it comes across. So let me diagram it out over here. So if we diagram this out, this will be CDH. We know X and X is right over here. We also know D is the 90-degree angle. And we're trying to find this right there. No, we're trying to find this right here. But you know, if this is X and that's X, isn't this a 45-degree angle? So that's the first thing I noticed. And then remember, we will learn, you could use Pythagorean theorem if you like, but we should recognize if this is a 45-degree angle, the hypotenuse, if you know the side, is just going to be a multiplier of square root of 2. So the hypotenuse of a 45-degree triangle is going to be multiplied the side by root 2, so this becomes x root 2. So that piece now is this piece right here. So I think we got it. So if you see this side here is x root 2, and then the side over here, FH. FH is now that little measurement that we want right there. So if we bring this about here, that triangle that I have now is C is over here, F is up there, and H. And I have my dimensions here. This is x root 2. That's x. And I'm trying to find the angle measurement right here. I'm trying to find angle C. So now I notice this is opposite relationship, opposite adjacent. So opposite adjacent relationship, that means it's going to be tangent. Tangent of theta is equal to opposite over adjacent. And of course the x's will cancel themselves out. So that means on top I'm just left with a 1. I'm going to keep it irrational. No point to rationalize it if I want to just plug it in anyways here. So on top I got a 1, on the bottom I got root 2. Take the inverse tangent of 1 over root 2. Plug it into the calculator here, and you should get something like 35.3 degrees, and we are done. That is the angle measurement that's formed based upon the conditions given. Alright, 2.3 is the soccer field problem here. So let me give you the diagram. This is from the textbook itself. And so at first we're trying to hit it from this corner here. We're trying to hit it into this little, let me see if I can zoom in. There it is. Let me zoom in on this. We're trying to hit it into this area here because the goalie is standing right here. And he can block 12 feet across. So I got this little pass right here. This is going to be 6 feet here, and that's going to be 6 feet because the top is 24 feet. And so as I'm looking at this here, it could be a little confusing until I find myself a right triangle. I'm thinking, where's my right triangle? Hold on. So if that's A, oh yes, B. B is going to be my 90 degree, and that's going to be the start of my right triangle. So from here, this is 54 feet. And then to the goalie box, the start of the goalie box is 45 feet. So this is a 45, 45, 90 triangle right here. Alright, let's see where we're at here. So the first thing is forming this little guy right here. That's A, that's B, and that's F. Not drawn to scale. But if that's 54, that's 54. I got myself a 45 degree angle. Now that's just to start with. Now we've got to move through the rest of them as well. So now let's zoom in again. So I got that one. I noticed this is 45. Now I'm trying to get this little middle section right here. So I'm going to extend this out now. So this is going to be now 54 degrees. Oh, sorry, 54 feet plus 6 more feet. So total, now I'm going to look at a 60-foot length right here. This still remains 54. So now I got my angle now as being D, BA, 54 feet. Now this is 6 feet including the part of the goalie box that I can hit into, and plus the remaining side. So 6 feet plus 54 feet should give me 60 feet altogether. So now I'm trying to figure out this right here. So what is, looks like opposite though, opposite. Looks like all these are going to be opposite over hypotenuse. So that's going to be tangent. Tangent of A is equal to opposite over hypotenuse. Taking the inverse, and we get ourselves 58.01, so 58.0. So now what I want, in order to get this little piece right here, this little sliver of a degree, I got to subtract. So if I subtract from the original 45, I get myself 3 degrees. So angle DAF is 3 degrees. Alright, that's one side. So I still have to keep on going here. So I guess my little question is, hold on, if that's 3 degrees, would the other side be 3 degrees as well or not? Would it be bigger? Would it be smaller? I guess we'll find out here. So, alright, before we move on, we have to, let's see, we have to get angle or triangle C. Looks like CBA is what we would need next. And then we're gonna get BA and then subtract it from CBA in order to get this little sliver as well right here. Alright, let's go for it here. So CBA is going to be the original 54 feet plus the 6 feet that we can hit into from the previous one, and then the 12 feet that the goalie will cover. So altogether I got 72 feet. One side, 54 on the other. And again, that looks like tangent to me again. Opposite over adjacent. Take the inverse of it. And voila, we should get something here. In this case, it's going to be 53.1 degrees. Alright, expanding out further. Now let's include the 6 feet that we can go into the goalie here. So this is now going to be all the way starting from E. So E all the way to B. So it includes the extra playing field of 54 feet plus the first side of the goal plus the person blocking, the goalie blocking, plus the next side. So it includes the whole entire goalie or goal post. Alright, that's going to be 78 feet now, so 54. So I'm going to look at tangent. Tangent of A is equal to 78 over 54. Take the inverse of that guy. Gets me 78 over 54. And I got a angle measurement user calculator 55.3 degrees. So that means the sliver that I want is between right here, between these two here. So angle CAB or CAE is going to be the subtraction of those two. Gets me 2.2 degrees, so it's not 3 degrees like we had originally here. Alright, and the directions do say, give me the sum of the two angles that I can hit the ball and wind up with a goal. So 5.2 degrees is my angle measurement that I can score on either side of the goalie. Alright, hopefully that was useful to you guys here. Hopefully you understood a little bit of the homework.